Evening everyone. So welcome to the 13th online session of the NPTEL course Polymer Reaction Engineering. So we have already completed all our regular sessions. Like the course was for the 12 weeks and we have completed 12-week lecture session, and today it is the last and final online tutorial session for this particular course Polymer Reaction Engineering. So today being the last class, we will try to discuss few more large number of questions. Usually we discuss around 30 questions approx plus or minus. But today I am trying to uh, discuss more number of questions, around 60 questions. So today, and these 60 questions are from all 12 books. So today it will be like a revision class, and we'll be discussing many questions that could possibly ask for your examination. Since we have completed all our assignments, now we are majorly focusing on examination, and possibly some of this question I hope will come for the final examination, and that will become very useful for you. So I have selected questions such that they what I feel are important, and they can be asked on the final examination. So without further ado, let's start today's class. So Uh, you all might have known me now, but still, let me introduce myself. I am Rahul. I'm Prime Minister's Fellow from the Department of Physics, IIT Kharagpur. I am the online TA who is handling this particular session. And yeah, let us start today's lecture. The first question that we'll be dealing is like, which one of the following statement is correct? Thermoplastic can melt on heating and solidify on cooling. The heating and cooling cycle can be applied several times without affecting their properties. The setting polymers melt first time when they are heated, and during the first heating the polymer is cured, and after that it does not melt on reheating and degrade after that. So, which is the correct answer? Just think for 1 or 2 seconds, then we'll discuss the answer. Okay, so we are having two statements. Statement one, which is about thermoplastic, and statement two, which is about thermosetting plastic. So it is said that thermoplastic will melt on heating and then it will solidify on cooling. But the important thing that we can note here is that it will heating and cooling cycle. That cycle can be repeated several times, and that doesn't affect the basic properties of this thermoplastic. So that is the first thing. It's true. The second statement is the thermosetting plastic or thermosetting polymers melt first time when they are heated, and during first heating the polymer is cured, and after that it does not melt on reheating and degrade after that. So that is a statement for thermosetting plastic. Not plastic, I mean it's thermosetting polymer. And the question is, which statement is true? Either both of them are true, either both of them are not true. First statement is true, second statement is false, first statement is false, second statement is true. The correct answer to this question is, it's not waste the time. The correct answer is both answers are correct. So these two are proper explanations. Just a second. These two are proper explanations uh, for the thermoplastics and thermosetting plastic. Okay, if that's the case, let's move on. Yeah, answer is both are correct. So let's move on. So the second question is, choose the correct option from the following for the word polymers. So which will actually define a polymer? The first one is, it means many mers or parts of same or different kind. It is complex in structure. Third option, depending upon the types of units attached to the main chain, it has different mechanochemical and thermal properties. The fourth statement is that it is simple in structure and have lower molecular weight. So these are the four statements. Just see which one actually denotes the our polymers well. Just think for a while. These are very easy questions. I think we can really move on. So the answer to this question is only the let's just say that only this 1 doesn't represent, right? It is simple in structure and have lower molecule. No, this is a wrong statement. This can be assigned to a monomer, but it is not for the polymer. Polymers are not single structure. They are a combination of monomers and they are complex in structure and they have really large molecular weight. They can have really large molecular weight depending upon number of monomers that are attached. Okay, so the correct options are A, B, and C. Okay, now let's move on to the third question. Yeah. This is a fill in the blanks question. Fill in the blank. Dash process is in which repeating units are combined to each other by a functional unit such as ester, amide, urethane, sulfide, and either with removal of small molecules, that is water, HCl, etc. So it's addition polymerization, chain growth polymerization, condensation polymerization, and all of the above. So which one is the correct answer? That's the question. Which one is the correct answer? Think for a while, then we'll discuss. Yeah, obviously we have discussed similar questions before also, so it will be easy for you guys to answer these questions. Again, let me give you a few minutes so that you can actually think over. Okay, let's not waste the time. The answer to this question is condensation polymerization. This is the answer. So basically, it says that some molecule there is a removal of small molecules such as water or HCl, and this particularly denotes the condensation polymerization. Okay, then let's move on. Let's move on to our next question. Pectin is a natural polymer which is used as a setting agent in gems and jellies, while vulcanized rubber is a synthetic polymer used to make durable tires. So which one is true? So I mean, are the both statements true, or is they are not true? So that's the question. Just think upon, then we discuss the answer. Just think. So the first statement is pectin is a natural polymer which is used as a setting agent in gems and jellies. While vulcanized rubber is a synthetic polymer which is used to make durable tires. So which one is the correct statement? Just think for a while and then we will discuss the answer. Okay, so I think this is a very easy question. So since we have such a good background, currently we have such a good background in polymer reaction engineering, it is very easy to answer this question. And the answer is true. Yes, the both statements are true. Pectin is a natural polymer which is generally used as a setting agent in gems and jellies, while vulcanized rubber is the synthetic polymer which is used to make durable tires. So both of these statements are true. Okay, so let's move on to our next question. Yeah, it's a true statement. The next statement is broadly, polymerization can be classified into two categories: step growth or condensation polymerization, and chain growth or addition polymerization. Statement 1, classification based on condensation, addition relies on the polymer composition or structure. Statement 2, the classification based on step chain relies on the polymerization mechanism. Okay, so these are the two statements. So it is said that basically we can classify polymerization into two. One is step growth, which is also called the condensation polymerization, or as chain growth, which is also called the addition polymerization. Now the first statement says that the classification based on condensation or addition rely on the polymer composition or structure. And statements 2 say the classification based on step chain rely on the polymerization mechanism. So which one is the correct option? So that's our question. Just think for a while, then we'll discuss the answer. Okay, just think for a while, then we'll discuss the answer. So Yeah, let's not waste the time because today we have to discuss lot of more number of questions. Okay, so here basically both statements are correct. This is the answer. Okay, fine. Okay, yeah, both statements are correct. Now the sixth question is choose the correct one for the dissociation energy of bonding force in polymer structure. Covalent bond greater than ionic bond greater than hydrogen bond greater than dipole forces greater than van der Waals forces. Second option is ionic greater than covalent greater than hydrogen greater than dipole greater than van der Waals. Third one is covalent greater than hydrogen greater than ionic greater than dipole greater than van der Waals. Fourth one is hydrogen greater than ionic greater than covalent greater than dipole greater than underline. So which one is the correct sequence? So which one has the highest dissociation energy and which one has the lowest dissociation energy? Yeah, again, this is a very fundamental question. So I hope everybody can answer. Right. So let's not waste this time in these kinds of easy questions. So definitely we know the covalent bond has the highest energy. Right. The covalent bond has the highest energy, followed by ionic bond, followed by hydrogen bonding, followed by dipole, and finally the least energetic one is the van der Waals forces. So correct option is option A. Okay, okay, fine. Then let's move on. So the seventh question is again it's a kind of true or false statement. So the first statement is polymer molecules are attached to each other with primary and secondary bonding forces such as covalent bond, ionic bond, hydrogen bond, and van der Waals forces, etc. Statement 2. When one or more pairs of valence electrons are shared between two atoms in the molecular structure, the form of a stable electronic octet shell to form a stable electronic octet shell. Okay, these are the two statements. Just think which one is true and which one is false, or both of them are true or both of them are false. Okay, so yeah, the answer to this question is both statements are true. Okay, both statement A and B. So these both are true statements. Okay, fine. So let's move on. Which of the following properties of a polymer is desirable during synthesis of polymer? So which one is the more polymer that is more which of the following properties is most desirable when we are actually synthesizing a polymer? Okay, so first one is lower molecular weight, impurity, low viscosity, all of these. Okay, so let me discuss the answer. The answer to this question is low viscosity. Okay, we generally prefer low viscosity because that can actually undergo further reactions more easily. Some polymer do need impurities and some polymer do need higher or lower, higher molecular weight. So the correct option is we generally tend to prefer low viscosity. Impurities can harm the, so yeah, impurities can definitely destroy the quality of the polymer. So the desirable quantity is lower viscosity. We need higher molecular weight. That's why we do polymerization. We need to remove the impurities, and lower viscosity is the one that is mostly desirable. Okay. So the ninth question is for diffusion controlled reactions, choose the incorrect option. These are the four options. Just try to read these four options and see which one is the incorrect option among this. Okay, I think you had enough time to read the answer in the options. So the correct option is chain termination step is not a diffusion control reaction. Option D is the correct answer. Okay. Okay. So let's move on. Which one is the incorrect for polymer molecular weight control? Which of the following is incorrect for polymer molecular weight control? Okay, just think, just read the above, and which one will actually lead, which one is actually an incorrect statement to control molecular weight. The first one is desirable physical properties of polymer products can be obtained by controlling molecular weight and distribution. Yes, that's a correct statement. Yeah, definitely. With the addition of small amount of monofunctional monomer, definitely we can control that with by applying this kind of monofunctional monomer. It will attach at one end, and there is no other end for further monomers to attach. So definitely that is a true statement. Use of non-stoichiometric amount of two reacting monomers will definitely lead to some kind of termination, right? That will lead to a control in the polymer molecular weight. So the correct option is option B, none of the above. Okay, and now let's move on. The morphological features in synthetic polymer are usually within our control. We can create them, influence them, and shape them to our design. So is this a true statement? So it says that the molecular features of synthetic polymers are usually within our control. We can actually control the morphological features of a synthetic polymer, and we can actually create them, we can influence them, and we can shape them to our design. We can shape them to our design. So definitely, this is a true statement because that is why we are generally using polymers. We can shape them to our needs. Okay, so this is a true statement. Okay, then let's move on. The crystalline transient temperature, crystalline domain temperature of a polymer is obtained by dash. Just read the statements and see which one is the correct one. Okay, so let's discuss. So the answer to this question is when the polymer is cooled and the transitional, rotational, and vibration energies are decreased. Okay, that is the answer. So when the polymer is cooled and transitional, rotational, and energies are decreased. It's the option A. So option A is the correct answer for this particular question. Okay. Polymer morphology. I'm sorry. Polymer morphology can be crystalline, semi-crystalline, amorphous, or all of the above. So which one is the correct one? Polymer morphology can be crystalline, semi-crystalline, amorphous, or all of the above. Which one is the correct one? Yeah, we don't need to think in these kinds. These are very easy questions, right? So the correct answer is all of the above. Definitely, polymer morphology can be any one of the above. Okay, it can be crystalline, can be semi-crystalline, can be amorphous. Okay, fine. So let's move on. Let's go to our 14th question. Which of the following statement is incorrect regarding the contacting pattern of flowing fluids in a reactor? Just read these sentences. They are such a long sentences. So just read these sentences once by yourself and then we will discuss the answer. Okay. So the correct answer to this question is option D, which is early mixing is most effective for single flowing fluids than two entering reactant stream. Okay, so they will run together and that will give give rise to reactions that can actually that can actually contribute to the entire polymerization process. So option D is the correct answer for this particular question. Okay, fine. Now let's move on to the 15th question. The rate of reaction is the function of which of the following parameters? Reacting material, temperature, concentration, type of reactor use. Okay, so we are actually talking about the rate of reaction. That is it. So which all parameters does it? Reacting material, temperature, concentration, type of reactor use. Just think for a while, then we'll discuss the answer. Okay. So the answer to this question is yes, reacting material, temperature, and concentration are the parameters that actually affect the rate of reaction. Okay. Okay. So let's move on. Let's move on to the next question. Which of the following variables affect the rate of reaction? Temperature, composition, pressure, all of the above. Again, this is a very easy question. Definitely, we know the temperature affects the composition effect, and definitely the pressure also. So the correct answer is all of the above. Okay. So the zeroth order reaction, for its zeroth order reaction, the unit of rate constant is dash. So we have discussed the general formula for this. Okay. So yeah, and the answer to this question is second inverse. So the general formula which we discussed was second to the power n minus 1 mole per liter to the power n. So this was the formula that we used, and by this we can get for when n is equal to 0, when n is equal to 0, we can get s is equal to 0 minus 1 mole per liter to the power 0, which is nothing but s inverse. So the answer to this question is s inverse. Okay, fine. So let's move on. Yeah. So the correct rate equation for a irreversible single reaction system is which of the following? We need equation for first order, zeroth order, and second order. So are those equations correct, or how many of the following equations are correct? Just think for a while, then we will discuss the answer. Okay. So yes, the first option is correct. It is the rate equation for first order reaction. Second one is also true. It is the equation for zeroth order reaction, and the mostly point one is also correct. Yeah, it is in the series. Now most of you are answered it already. So let's move on to our 19th question. So the question is for second order reaction with equal of feed concentration, the rate equation can be written as we have already seen this. So the option is option B. Okay. Now let's move on to our 20th question. Select the incorrect statement for half-life of a reaction. The half-life for zeroth order reaction is Ca naught by 2K. Half-life for first order reaction is 0.693 by K. Half-life for second order reaction is 1 by C naught by K. And for the first order reaction, the half-life is a function of concentration. Which one is the incorrect statement? So definitely we have two options. There is B and C. These two are contradictory to each other. So the first one says it is the first one. We can see it is independent of the concentration, and so the option D says that it is should be a function of concentration. And correct or the incorrect statement is option B. So actually, for first order reactions, it is independent of concentration. Okay. So let's move on to the next question. Certain first order reaction is completed in 15 minutes. The rate constant of the reaction must be dash. Okay, so we know the general formula. It was something like R is equal to K times R naught e to the power minus lambda t something, and it says that R becomes R naught by 2. So we can generally say, and rearranging, we can finally get the answer as this one. So the point, it will basically become log 2 by 15 minutes. Basically, when we solve this, it become log 2 by 15 minutes. Okay, so this will give an answer 0.0462 minute in use. So this is the answer. Okay, okay, that's the answer. So let's move on. The correct relationship between single pass conversion and overall conversion in a recycling reactor is dash. So we have four options. Just think which one is the correct option. Basically, they are playing with the brackets here. So which one is the correct one? Okay, fine. So let us discuss the answers. So the answer to this question is option A. This is the correct statement. Okay. Okay, fine. So let's move on. Yeah. Now choose the correct option for the concentration of the reactant X in the reaction X becomes Y becomes Z if the reaction X is decomposed into product Y in first order kinetics. Which one is the correct answer? It said that X become Y in first order kinetics. Which one is the correct option? Generally, we need to know the general formula of equation here. If we know that, then definitely this question is a very easy one. Right, I think I'm going a little faster. So let's go a little bit slower. I'll give you more time to think, just think, and then move on. Okay, so the answer to this question is option A. This is the correct option. Okay, Cx by Cx naught is equal to e to the power minus k into t. So this is the correct option. Okay, now let's move on. For a recycle reactor, select the correct option. There are multiple options here. Just try to read and I'll discuss the answer later. Okay. So the correct answer is, there are multiple options are correct. So the correct answer to this question is, the product steam is split and returned to the entrance of the reactor. The ratio can be defined as the ratio of volume entering at the entrance of the reactor to the volume of volume leaving the reactor system. If recycle ratio R is infinite, then the recycle reactor approach to mixed flow reactor, and if R is 0, then recycle reactor approach to PFR. Okay, so these are the statements. So now let's move on. So this is the 25th question. If recycle ratio is R is infinite, then the recycle reactor approach to plug flow reactor PFR, and the performance equation of the recycle reactor will become same as the performance equation of PFR. So this is a true statement or a false statement. Just think for a while, then we'll discuss the answer. Okay. So actually this is a false statement. Okay, it doesn't become a plug flow reactor. The recycle reactor with recycle ratio is 0 will make R will not become a plug flow reactor. So let's move on. So this is a four statement question, two statement question, and there are four options. We have to say which one is correct and which one is wrong. So yeah, so the first statement is an autocatalytic reaction system. One of the product act as a catalyst. In statement 2, to start a autocatalytic reaction, there is a need for small amount of product. So which one is correct? Just think for a while, then we'll discuss the answer. Okay, so the correct answer is both of the statements are true. This is the correct answer. Now let's move on. The step growth polymerization process reaction begins rapidly, but higher molecular weight is obtained slowly at the end of the process. This thing, is this a correct statement or false? It says that in step growth polymerization process, it begins rapidly, but higher molecular weight is obtained at the end of the process. Just think for a while, then we will discuss the answer. Okay, so the answer to this question is this is a true statement. Okay, this is a very true statement. Let's move on. So this is a two statement problem. The first statement says that a small change in the molecular weight led to a higher molecular weight at the end of the polymerization process as large molecules of polymer bind together. Statement 2 states that the average molecular weight is limited by the reaction equilibrium. So this statement 1 is true and statement 2 is false. Statement 1 is false, statement 2 is true. Both statements 1 and two are true. Statement 1 is false and statement 2 is false. So which one is the correct option? Just think for a while, then we'll discuss the answer. The correct answer to this question is both statements are true. Okay. Now let's move on to the next question. This is a fill in the blank constant question. In dash, a step growth reaction occurs in the homogeneous molten polymer at the temperature above melting point of the polymer. Light condensation, solution condensation, superficial condensation, immersion condensation. So yeah, there is no point in discussing the question. Already the answer is there. Anyway, the question is also listed. The answer is melt polycondensation. Okay, so let's move on. The average molecular weight obtained in a step-growth polymerization is limited by rate of reaction, reaction equilibrium, rate of diffusion, sum of the above. Good. So which one is the correct option? Just think for a while, then we will discuss the answer. The answer to this question is option B, reaction equilibrium. Okay, so this is the correct answer. Okay, now let's move on. Which of the following polycondensation technique is useful in manufacturing of reverse osmosis, encapsulation of inks, insecticides, and medicines? So just take which of the following is the first one. Okay. So definitely there is something for this reverse osmosis, and this is a interfacial process, and definitely from that itself we can say that it is the answer is interfacial polycondensation. Okay, now let's move on. The termination in the ionic chain polymerization can be through recombination of counterions forming sterically hindered ion having very broad charge distribution, forming a sterically hindered ion having a very narrow charge distribution, none of the above. So which one is the correct answer? Just think for a while, then we'll discuss the answer. Okay. The correct answer is there are multiple options are actually correct. The first one correct option is recombination of counter ions, and the second option is forming strictly hindered ions having very broad range of charge distributions. So A and B are the correct one. Okay. Now let's move on. Move to the next question. So this is also two statement question. The first statement is that the free radical species formation occurred through homolytic cleavage. The second statement is that the number of free radical species present in the system should always be high to propagate the radical change polymerization. So the statement 1 is true, statement 2 is true, statement 1 is false, statement 2 is false, statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true. So which is the correct option? Just think for a while, then you will discuss the answer. So the correct answer is the statement 1 is true, but the statement 2 is false. Okay. So option C is the correct one. Now let's move on. Following are the characteristics of chain growth polymers. Which are the basic characteristics of chain growth polymers? Just read once and just see which are the possible characteristics of chain growth polymers. It's an easy question. I hope everybody can answer. So yeah, just read the question once and read the systems. Okay. So the correct answer is formation option A, formation of high molecular weight polymers from unsaturated monomer. Then the second one is required initiator to start the reaction. And the option E, the polymer molecular weight is largely unchanged to the average percent conversion of monomer to polymer and increases with the time of reaction. Now let's move again. Let's move on to the 35th question. Here, statement 1. Ionic polymerization is monomer selective. That is, specific type of monomer can be polymerized to specific kind of ions depending upon the resonance characteristic induced with the specific functional group. Statement 2 is radical polymerization can be usually used to polymerize most of the addition polymerization species. Which one is correct? So the correct option is both the statements are true. Statement 1 is true and statement 2 is true. Okay, so now let's move on. During ionic polarization, the polarity of the solvents affect the polarization reaction, and hence the preferably the polarity of the solvent should be low polarity, moderate polarity, high polarity. Water should be added to increase the polarity. So which one is the correct one? Just think for a while, then we'll discuss the answer. Okay. So the answer to this question is it should be of moderate polarity. Okay, fine. Now let's move on. Let's discuss the next question. The rate of disappearance of initiators in chain polymerization reaction generally follows zeroth order kinetics, first order, second order, third order. So which one is the correct answer? Just think for a while, then we will discuss this. Let's read the question for a while, then we'll discuss the answer. So the answer to this question is it follows basically first order analytics. Okay. All these questions will be uploaded on the Google Sheet. So if anyone has any doubts, you can just go through the questions once again. Okay. The influential factors that are covered in the term cage efficiency are caging due to interface from solid molecules, recombination of free radicals due to caging effect due to interference from surrounding humidity and temperature, caging effect surrounded occurred due to interference of ions. Just think for a while, then we'll discuss that. Yeah, the correct answer is caging due to interference from swollen molecules and recombination of free radicals due to caging. So these are the correct options. Now let's move on to the next question, which is inhibitors are used to start the termination of the polymerization reaction to avoid premature thermal polymerization during transportation and storage, to avoid ionic species formation during polymerization reaction, and all of the. So which one is the correct answer? Just think for a while, then we'll discuss the answer. So yeah, the correct answer is to avoid premature thermopolymerization during transportation and storage. Okay, so now let's move on to the next question. The rate of propagation for radical polymerization involving inhibitors is directly proportional to concentration of inhibitor, directly proportional to square root of concentration of inhibitor, inversely proportional to concentration of inhibitor is inversely proportional to square root of concentration of inhibitors. Which one is the correct answer? Just think for a while, then we'll discuss that. Okay, so the answer to this question is inversely proportional to the concentration of inhibitor. Inversely proportional to the concentration of inhibitor, which is option C. So that is the correct answer. Okay, okay, fine. Now let's move on. The technique which uses the change in volume of polymerization solution as a parameter to determine the polymerization technique is mass spectroscopy, precision technique, precipitation technique, dielectrometry, and NMR technique. So which one is the correct one? Just think for a while, then we'll discuss the answer. So the answer to this question is dielectrometry. So dielectrometry is a technique where we actually measure the polymerization by measuring the change in the uh, volume of the solution. Okay, now let's move on. So which of the following compounds can be used as an initiator in aqueous medium? Hydrogen peroxide, formic acid, hydrazine, sulfonic acid. Just think for a while, then we'll discuss the answer. Okay, fine. So the correct answer is hydrogen peroxide. So A is the correct answer. Now let us move on. Yeah, again the answer is already given, so there is no final responsibility for you to think. So the rate of initiation for photopolymerization is directly proportional to quantum heat, and it is directly proportional to the intensity of the absorbed light. So the correct options are option A and option C. Now let's move on. So the rate of propagation for photopolymerization is, this is propagation, the letter in the previous question was for initiation. Just think for a while, then we'll discuss the answer. So yeah, the answer to this question is it's directly proportional to square root of quantum mean and is directly proportional to square root of the intensity of light. So Okay. Okay, fine. Now let's move on to the next question. So the device that is used for calculating the intensity absorbed light during polymerization is dielectrometer, actinometer, tensiometer, rotameter. So which one is the correct answer? Just think for a while, then we'll discuss the answer. So the correct answer to this question is actinometer. So generally, actinometers are the device that actually calculate the intensity of absorbed light during polymerization. Okay. So let's move on. So this is two statement question. The first statement is if a person wants to prepare high impact polystyrene and acrylonitrile butadiene styrene copolymer using bulk bead suspension polymerization. The water and dispersion should be added before the phase inversion of monomer solution. The statement 2 states that this step of water and dispersion addition is required to sustain the polymerized bead. So which one is the correct statement? Just think for a while, then we'll discuss the answer. The correct answer is statement 1 is false and statement 2 is true. Statement 1 is false and statement 2 is true. Let's go to the next question. Statement, this is also a statement question. It says that in semi-continuous and continuous immersion polymerization, sufficient free emulsifier is usually required to stabilize the oligoradicals that precipitate in the aqueous phase. Statement 2 states that in semi-continuous and continuous emulsion polymerization, sufficient free emulsifier is usually required and to saturate the surface of existing interfaces and form cellulase. So which statement is true? Statement 1 is true, statement 2 is true, statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true, statement 1 is false, statement 2 is false. So which is the correct option? Just think for a while, then we will discuss the answer. So the correct answer to this question is statement 1 is true and statement 2 is true. So both the statements which is mentioned here are true. Now let's move on to the next question. In bead form of suspension polymerization, the polymer is dashed in its monomer and thus the monomer mixture is dashed. Choose the correct options in sequence. Soluble homogeneous, insoluble homogeneous, insoluble heterogeneous, soluble heterogeneous. Just think for a while, then we'll discuss the answer. The answer to this question is soluble and homogeneous. The In weak form of suspension polymerization, the polymer is soluble in its monomer and thus the monomer polymer mixture is homogeneous. So this is the correct answer. Now let's move on to the next question, which is our 49th question. For population balance modeling in suspension polymerization, consider a case where two drops are colliding and continuous phase liquid film is stuck between these two drops, which stops them from coalescing. For draining the liquid film, dash energy is triggered. Energy of the triggered drop oscillation must be greater than the energy dash. Between drops to drops, the drop ring is interrupted until the liquid film is fully drained. The correct and the options are kinetic adhesion, potential cohesion, anti-cohesion, potential adhesion. So which one is the correct answer? Just think for a while and then we will discuss the answer. So the correct answer is kinetic energy and adhesion. Option A is the correct answer. Now let's move on to the next question, which is a 50th question. During drop coalescence process in suspension polymerization, the drop will coalesce if the energy of collision is dash than the total drop surface energy. Which one is the correct, greater or smaller? Just think for a while, then we will discuss the answer. Correct answer to this question is greater. Okay. Okay. Fine. So let's move on. Next question is particle nucleation will occur due to both homogeneous and heterogeneous nucleation mechanism. We choose correct answer. Monomers of water soluble, monomers of water insoluble. Concentration of surfactant is not enough. It's very strong. It's actually enough. Enough for the formation of missile list. The concentration of surfactant is very high that the missile formation can be easily occur. So yeah, new answer is already given here. So the correct answers are should be water soluble and the concentration surfactant is very high that the reservoir formation can be easily occur. So these two are the correct options. Okay, okay, fine. So let's move on to our next question. Statement states that the advantages of operating emulsion polymerization reactor under limited monomer supply maximizes the production of rate and yield. So is this a true statement or is it false statement? Just stay for a while, then we'll discuss the answer. The correct option is option B, false. This is a false statement. It is a false statement because actually we should have an optimum amount of polymer. The supply should be an optimum. It should not be so high, but it should not be so large. And here it says that it should be limited. Definitely that's a false statement. It should be in real life. It should be a optimized. Okay. Okay, fine. So let's move on to the next question, which is pulsed tubular reactors are better than single pass tubular reactors as they provide improved mixing, less pressure drop, easy cleaning and reinstallation, all of the above. So which one is the correct answer? Just think for a while, then we will discuss the answer. Okay, so the correct answer to this is it will actually provide improved mixing. That is the reason why pulsed tubular reactors are better than single pass tubular reactors. Okay, fine. Now let's move on to the next question. Emulsion polymerization reactors could allow fine-tuning of the polymer microstructure, be useful to prepare many different grades in same reactor, be adaptable to a wide range of production grades, and all of them. So which one is the correct answer? Just think for a while. Then we discuss the answer. correct answer for this question is all of the above. So these all are the possible properties or that I mentioned polymerization reactor should have. So the answer to this question is all of the above. Now let's move again. Let's move forward. So this is our first question. In ideal batch reactor, the composition of the product changes with time in reactor, so it operates under unsteady state operation. Okay, think for a while, then we'll discuss the answer. Okay, so the answer to this question is option A, true. So this is a very true statement. So in ideal batch reactor, the composition of the product changes with time in reactor, so it actually operates in the unsteady state operation. Okay, okay, fine. So let's move on to the next question. Which is the most suitable for the given statement? Statement 1. Ideal mixed flow reactor operated in steady state condition. Batch reactor, the reactors are changed and the following flow of following with mixed thoroughly react for certain time period and then discharge. So which one is the correct one? Just think over the question. There are four options. Just think and yeah, that's it. Okay, so the answer to this question is statement 1 is correct and statement 2 is correct. Okay, so statement 1 is correct and statement 2, which is our option C. Now let's move on to our next question. Yeah, that's the correct answer. So let's move on to the next question. For the equilibrium consideration in a closed system, the relationship between the degree of polymerization and equilibrium constant K can be represented as follows. Just see the following equations and just tell me which one is the correct answer. I'll give you a few minutes to think. Now, Okay. So the answer to this question is 1 plus k to the power 0.5. So it's option B. Okay, now let's move on to our next question, which is a 58th question. So total I have prepared around 60 questions today. So this is a 58th question. So the question is, which is the incorrect for controlling the molecular weight in linear polymerization? So these are the four options. Just read through and which is the incorrect option. Okay, just think for a while, then we'll discuss the answer. So the correct answer to this question is addition of a bifunctional monomer. So this is the answer because we are actually trying to control the molecular weight, and if there is a bifunctional monomer, that can actually lead to certain other reactions, and hence we cannot have a control over the uh, molecular weight. Okay, okay, fine. Now let's move on to the next question. Yeah. So in ionic polymerization, the process where the ion energy provided by the UV radiation is not enough to conduct the direct ionization, but still ions formed by the phenomenon called or phenomenon termed as dash. Monophotonic excitation, biphotonic excitation, scavenging excitation, or none of them. So which one is that one? Answer, just think for a while, then we'll discuss the answer. So the correct answer to this one is biphotonic excitation. Is the correct answer. For this question we have discussed in the last class. I think you guys will remember. Okay, now let's move on to our last question for today's session. So, if the growing polymer hold their growth tendency indefinitely, then it is termed as dash. Emulsion polymer, dipping polymer, radical polymer, ionic polymer. Let us wait for a few seconds or few minutes, and then we will discuss the answer. So answer to this question is living polymer. So living polymers are like the growing polymers that hold their growth tendency indefinitely. Okay, it is termed as living polymer. Okay, fine. So yeah, these are the few references that I've used. And thank you so much for having patience and spending your time in listening to my lecture. I tried my level best to give it 100% to these forming questions and discussing it with you. I think these are useful for you, and definitely prepare for examinations well, and everybody try to write the examination so that you can get a proper certificate. Thank you all. Thank you all for listening. I'll be here for a few more minutes. If you have any doubts, just ping me. I'll be here itself. I will be waiting for your responses for a few more minutes, and then I will just turn off the meeting. Okay. So yeah.